Well, everybody, as always, I would certainly encourage you to augment these experiences on the videos with reading. I got to tell you, these chapters are different. What we're about to get into in 7 and 8 is not anywhere near as difficult as calculus or trigonometry, in my opinion. However, it is just different. It's a different way of thinking of things. It's using existing math principles that you may very well be familiar with, but it's approaching things in a different way. So please take both angles. You know, the class that we would have, or the time rather, that we would have spent in class is plenty of time left over for reading and for watching these videos. And chapter 7 can be mastered. It really can. It's just a different way of thinking of things. And we've got just 2 new baby equations that are introduced in this chapter. So what's it all about? Chapter 7, probability and sample means. And we're going to talk about this new thing called the distribution of sample means. No longer a distribution as we were drawing in black in class. That was a distribution of individual scores that was presumed to be normal. This is a distribution of sample means. If you can imagine means stacked on top of each other in that case. So it's a different thing. And where is the distribution of sample means derived from? It's derived from that original black population that we've drawn in class. And I'm mentioning the colors black prominently, and eventually we'll mention blue prominently, because black will stand for the original population from which things came, and blue will be the distribution of sample means. So I want to delineate that right away. So let me clarify a couple things right away. Sampling error, the natural discrepancy or amount of error between a sample statistic and its corresponding population parameter. We've already covered that. And by the way, sampling error is to be expected. That's not a sign of slovenliness or sloppiness on behalf of the researcher. It's actually unavoidable. So we'll see some sampling error. And by the way, the measure of sampling error is going to be something that I'll describe as the standard error. Let's not get into that just now, but we'll define that here in a few minutes. Again, the distribution of sample means. Let's just read the formal definition. And of course, this is right out of the Graviter and Wallnow text. Is the collection of sample means for all the possible random samples of a particular size of n. And that n could be 4 or it could be 256 that can be obtained from a population. For particular reasons, we know what that distribution of sample means looks like. And we'll get into that here in our discussion together. But again, one more time. The distribution of sample means is the collection of sample means for all the possible random samples of a size. And that could be anything. It could be 2, could be 1,000 that could be obtained from a population. In the abstract, that may not make much sense. Let's get into the particulars. And by the way, here's what it would look like. Here's an example of a typical distribution of sample means. What you're seeing there in those small boxes, not individual scores, but actually means from one sample. So if you can imagine all the means from one sample that are taken, and those are represented by each of those boxes, we're no longer speaking of individual scores. So let's take this population, as crazy as this sounds. Imagine if we had a population of only 4 scores, 2, 4, 6, and 8. You can tell by looking that the mean is 5. If I added 2 plus 4 plus 6 plus 8, gosh, what would I get there? 20 divided by 4, and again, surely it just leaps off the page that the mean is 5. But pretend that was our whole population. Then what we could do is create a distribution of sample means. And I want to draw your attention, of course, to the table at right. This is the way that is presented in your book. This is an exhaustive sample of, let me say that again, an exhaustive distribution of sample means where the size of the sample is 2. And from each of those samples of size 2, I can garner a mean, as I've done over on the far right. Now, I want to leave that here, but just peruse at that for a second. We'll pick up on this in the next clip. But this is a very concrete illustration of a distribution of sample means. It could hardly be more direct, and I'll walk you through each of these 16 steps here in our next clip.